Hello friends, I am Dr. Amit Gangwal, Associate Professor at SVKM's Institute of Pharmacy Dhule. In this ongoing video series as part of online certificate based course on AI in pharmaceutical sciences, we are discussing about most crucial part, that is deep learning, because deep learning is the visiting card for AI, which is an umbrella term. Most of the complex type of applications of AI which we are using is based on deep learning, which is a type of machine learning. We all know deep learning means a structure consisting of hidden layer, input layer and output layer. As you might be seeing on this cover title slide, images of cats and dogs are there. After training different feature extraction through input to output layer, the output will be cat. So model training is required. Already we have seen in few videos about basics of deep learning, which involves continuously changing the tweaking or fine tuning of the weights and biases associated with the individual feature of the input. In this particular video, we will talk about autoencoders. In two videos, we will summarize what is the meaning of autoencoder. And most of the difficult types of applications like complex interplay between the input features is decided by autoencoder. So we will talk about general, that is standard or vanilla autoencoder. We will talk about adversarial autoencoder. We will talk about variational autoencoder and generative adversarial neural network before we go for summarizing all of this in second and concluding video. So without taking much of your time, let me proceed for this topic, autoencoder. So there are two terms, chemical space and latent space. So chemical space is a concept or an idea in machine learning. The meaning is to organize or to place different types of molecules in different spatial arrangement. So all the molecules which are having same scaffold or same type of physico-chemical properties, they will be placed in one cluster and others will be at somewhat distance from that particular cluster. So chemical space is an idea to organize molecular variety by assuming that different molecules occupy diverse regions of a mathematical space where the position of each molecule is determined or defined by its properties. So it is said that total number of small molecules which may have the potential of becoming drug is 10 to the power 60. So it is beyond human comprehension, however intelligent the human may be. So here comes the role of AI and particularly deep learning to analyze the properties of different small molecules and to make different sisters or brothers, that is different type of what we call it molecules resembling to the training set of molecule. Another word is latent space. Latent space means a representation of compressed data. Latent means hidden, dormant, not active. So here in terms of deep learning, the meaning of latent vector or latent space is to compress the features of particular input without any harm or without losing the identity or the inherent or the meaning of the input data. So latent space is useful for learning data features and for finding simpler representation of data for analysis. So for example, you are training a deep learning model for identifying image of cat and to differentiate images of cats from those of dogs. So here your deep learning, that is autoencoder, will take only those features which are responsible and which are making a cat a cat. So those pixels or features of the cat image will be compressed and unwanted one will not be accepted or extracted as a feature by the deep learning model. So classical machine learning approach before the arrival of deep learning models, it was like QSAR, that is quantitative structure activity relationship, which involved to have lot many virtual drug like molecule drug candidate, and the question is, can this molecule activate this target? Means you have the molecules and you have to answer the question through some techniques whether it will drug the protein. On the other hand, de novo does the inverse or reverse activity. De novo design attempts to answer, can we generate? This is the beauty and this is the most talked about type of features of deep learning, not only in drug discovery or pharma or health domain, but in all the fields, domains, businesses, activities. This is the most important type of applications of generative type of deep learning model. So autoencoder, basically its different types are known as generative type of deep learning model. So in classical QSAR, the question is, what is the property of those drug like molecules virtually generated on a screen, or can these drug like molecule activate or drug the target protein? On the other hand, de novo design attempts to answer the question, can we generate a molecule which is able to activate this target? Or I simplify this statement, can we generate a molecule which has so and so physicochemical properties? So if you remember, several times in earlier videos I have talked about a beautiful infographics designed by in silico medicine team. In that image on left there is one diagram and the title is classical drug discovery is finding a needle in the haystack. On the right side in the same infographics they have mentioned that through AI you can generate your own needles. You can customize n number of needles as per your demand, as per your essential features. So here goes the same point. De novo design attempt to answer, can we generate a molecule which with so and so property, or can we generate a molecule which can activate the receptor, or can we generate a molecule which can drug a particular protein target? So here comes the role of variational autoencoder. We will talk in later section of this video. It is a neural network which encodes an input molecule into a vector, which is basically a storage space for the molecule's structural data or feature or descriptor, and then decodes that vector to a group of smiles that matches the input molecule. So already n number of times we have discussed the meaning of vector, smiles and other things. So we will talk about now a basic structure of autoencoder. So here you are seeing it's a simple autoencoder. This is the input layer, this is the output layer. So for example, you have given the image of cat to this encoder. Encoder will encode the image into a latent vector. It means it will take only those features from the image or input which are required as identity function for the particular input. So this input layer will take only required features, and in the hidden layer it will compressed. From compressed latent space, decoder, it is decoder will try to generate same image or same item as the input, right? In another example, it is the general concept, right? In case of drug discovery or chemistry or pharma domain, encoder will do same job, but this is the variational autoencoder, and this one was simple, plain, standard, classical or vanilla autoencoder. In case of variational autoencoder, this will take the molecule as the structure, input structure, and this will be the smile string, the way to show molecule to the machine learning model, and this will be encoder. We all know there are three basic structures in the architecture of the autoencoder. One is encoder, one is bottleneck or the compression function, and third is decoder. Encoder will convert your input into compressed fashion. Decoder will go for reverse phenomenon. It will make again the same input from the compressed space, right? So the encoder makes two vector also. One is standard deviation vector, another is mean vector. and from this you will go for sampling. From this latent space which is generated by the encoder, you will take latent vectors and you will decode them, and you will get similar type of molecules as the input molecule. So here this is the latent space. Understand, it is very important. This is our input structure. We converted it into Ismail fashion, Ismail string, so that machine can understand the meaning. It is a sequential way to represent the data in terms of molecular structure. Encoder will convert this Ismail string into latent space. What is the meaning of latent space? If you remember the first slide of this presentation, this video, the space, a concept where similar molecules are placed together and different or molecule of different variety are placed in different areas in the space. So from those area you will pick one molecule and you will decode into actual molecular structure. So you will come to know, if you have properly trained the autoencoder, then if you sample something from the latent space or you pick something from the latent space, you will get exactly same molecule with the same features, plus minus might be there compared to input drug molecule. So it is called generative model. Just by training your latent space by hundreds of molecules, you can generate thousands of similar molecules which may or may not have similar properties, but they can be further identified and modified based on the model training. This is the basic structure of autoencoder. So let me read the description now. I will talk about the second diagram here. So given a molecular representation as input, the molecule was acetic acid. An encoder outputs both a mean vector and a standard deviation vector. These vectors are used as parameters of a normal distribution. So based on the features of the acetic acid, your encoder will keep together all the probable chances of those molecules which have something like structure of acetic acid. So it is called normal distribution. For normal distribution, we need two vectors, mean vector and standard deviation vector. These vectors basically contain the numbers, that is mathematical values are there, and which those values represent the meaning of the acetic acid. Meaning means the features or the property of the acetic acid structure. So from acetic acid, the encoder has made a latent space. So latent space has all the probable molecule like acetic acid in the close vicinity in different clusters in the spatial arrangement. Now, this latent space is used as the input for a decoder network. Now, decoder will sample or take or pick one particular point, and which outputs a molecular representation, that is here glycolic acid in this example. The loss function for variational autoencoder, loss function means the difference between the actual output and the output given by the model. They should be same. If they are not same, you have to further fine tune the model output so that the output of the model will be similar to the expected or the actual output. The loss function for variational autoencoder training consists of two components. It is very, very important. The training involves two type of points. One is, the first part is the reconstruction loss, ensuring that the original input resembles the generated output. Suppose you have given the image of acetic acid, encoder will convert it into latent vector, and then decoder should generate an image which is almost identical to the input. This is the first job of autoencoder. And second is, the second component encourages similar molecule to cluster together. As I told you, all the molecules which are almost similar to each other, they should be in particular cluster or the point in the space. In this case, the structurally similar glycolic acid and oxalic acid are close in the latent space, while the less similar gamma butyrolactone is further away. After training, the encoder portion can be discarded. Now you have made a latent space from the encoder. Now there is no use of encoder. From the latent space, you sample, you peak, you choose one particular data point, and you will get a particular molecule. and new molecules can be sampled by sampling different z vectors from a standard normal distribution, and this is called generative model, because after training you are leveraging latent space to generate new molecules entirely from scratch. They may or may not be in this world, but their structures may be first time given to you by the system. Now, based on chemistry, based on their synthesizability, you can go ahead or you can further fine tune to make chemically valid molecules through using the help of RDKit type of cheminformatic libraries. So to simplify it, what is the meaning of latent space? So for example, you have different data points, like sailboat, schooner, yacht, steamer, cruiser. So you have a dictionary. So dictionary will, for example, you want to classify a dictionary into latent space. So all these similar words, similar structures will be placed in a single vector. So it is called a latent vector because they have somewhat similar function or somewhat similar structure or somewhat similar physico-chemical property in case of chemistry. The underlying idea is that latent features are semantically relevant aggregates of observed features. When you have large scale, high dimensional and noisy observed features, it makes sense to build your classifier on latent features. So these are the latent vector having some similar items put together. Another example is how Netflix, YouTube store your data and how they recommend you the stuff or the product as per your choice. Another example, consider the case of users to movie rating metrics like the Netflix setup, because there are different movies falling in the category of sci-fi movies, romantic movie, comedy movies, thriller, action, drama, suspense, other type of genres are there. Each genre will have further thousands of movies, so they don't preserve, they don't store, they don't analyze your data based on individual movies. Rather, they analyze and store your data in the latent space based on your course type of liking. Then they go for course to fine tuning. Say for example, all your movies you are watching belong to category of action, thrillers or suspense, so they will put all your choices in a single vector, and in that vector they will keep all your choices. So they are making it course to find. They are not writing name of individual movies, they are identifying your choices of movies, which genre you are choosing, then they recommend you in future. So I read here, each user of Amazon Prime or Netflix, for example, will have a specific preferences like sci-fi movies or romance movies. So instead of storing all the movies ratings, one can store a single latent feature like the movie category, which belongs to different genres, for example sci-fi or romantic movie, whichever quantify his taste for each category. These features are called latent features, which capture the essence of her taste rather than storing the entire movie list. Though this will be an approximation, but in this way very little information is to be stored. Means you have compressed the liking or the habits or the preference of the user or the watcher or the subscriber based on his taste. So this is the structure of autoencoder, plain or standard autoencoder. This is your image input. This is your input having some features, two eyes, type of this what we call whisk, and this space between these eyes, type of pixel color, and so on. They are the features. So encoder will take only responsible features and compressed into latent vector. From latent vector in reverse direction, all the features will be further decoded by decoder, and it will try to give you similar image. This is the main function of the autoencoder. Here, to convert this image into different vectors, you have to take the help of convolutional neural network, CNN. Very recently we have seen that particular video, if you remember. So this is the application of autoencoder. You have an image, you can change the color. or you can add something. You can remove background noise also if you don't want. So all this is possible by autoencoder or generative type of deep learning model. First you will train the model, then it will understand things. So here input is image is, this is an image. It sounds like some historical images there. This is the noise, unwanted stuff is there. So encoder will make latent space, and from it it will generate more and more images. So one of the images can be like this without any noise or the flash is being shown here. So another example, this is an input image of 2. For example, it is a handwritten, manually written image of 2. So encoder will make various uh, clusters in latent space in compressed reconstruction fashion. Here again you would need convolutional neural network. So after proper training of the latent space, decoder will pick one particular point and it may generate one image which is without any noise, and it is called denoised image. So ultimately from your own input data type, it is making the final or beautiful or flawless or perfect type of images or the output just based on your input. So how it is possible? From latent space, which is the compressed representation, the features will be isolated and you will get the proper result. Autoencoder is a neural network architecture for unsupervised feature extraction. An autoencoder is a neural network which is trained to produce an output which is very similar to its input. So it is chiefly any attempt to copy its input to its output. And since it does not need any target label, it can be trained in an unsupervised manner. Because we all know supervised means you should have input and output both together. This label. So now we are coming on to theory portion after a lot many example. An autoencoder consists of two neural network. The encoder network, which converts the molecular information in case of chemistry or drug discovery, or in pharma segment, it converts the molecular information to a description vector called the latent space, while the decoder network is designed to convert a latent space vector into a molecule. The encoder layer encodes the input image as a compressed representation in a reduced dimension. This is the main function of autoencoder from encoder point of view, to make image a compressed version in reduced dimension. The compressed image is the distorted version of the original image, and we don't know what's happening inside those encoders. The latent space is simply a representation of compressed data in which similar data points are closer together in the space. Means there are different clusters in latent space. Those points which are having similarity, they will be in close proximity. Latent space is useful for learning data features and for finding simpler representation of data for analysis. So if we save the encoder vector of an image, that is this one, we can reconstruct or we can sample more points just by passing it into the decoder portion. So now we will come out encoder. What is the job of encoder? We are reading in detail because it is most important from drug discovery point of view. And repeatedly I am telling you, the main point of AI in pharma industry is to speed up, to make entire drug discovery marathon economic, fully innovative, productive, and affordable from patient's point of view. So this is the main application of AI in pharma industry. Remaining all examples are not that much important, and already pharma industry is fully automatic. Only minor incorporation of AI will make it further advanced, but the only area or department of pharma industry which is lagging behind in terms of output is drug discovery. And these all the models, that is autoencoder, they are being used heavily by AI and pharma company to make or to generate, that is de novo drug designing for making affordable and faster drug molecule in the world. So what is encoder? It takes an output, it takes an input. An input can be image, molecule, word embedding, for example sentence, video or audio data, anything it can take, and produces an output, where output typically has a lower dimensionality than input. For example, the encoder can take an image of size 1000 by 1000 pixel and produce an output edge, also known as latent code, of size 100 by 10. So you have reduced the size or the features or the dimensionality of the structure without compromising with the identity or the meaning of that particular input. The encoder in this case just compresses the image such that it will reside in a lower dimensional space. So in case of drug discovery, an encoder converts each smile string a way to represent chemical structure into a fixed dimensional vector, and a decoder network which converts vector back to the string. The autoencoder is trained to lessen error in reproducing the original input. It means it attempts to learn the identity function. It never forgets what is the identity and what is to be saved or extracted or preserved or stored or studied from identity point of view. Main point here is the mapping of strings through an information bottleneck. This bottleneck is the fixed length continuous vector. It is important. Continuous vector means all similar data points are together. There is no gap or sparse matrix is not there. Continuous vectors are there. You can pick or choose or sample any of the vector, and chances are that it will have some features similar to the input or the desired attributes. So this bottleneck induces the network to learn a compressed representation that takes only the most salient information from viewpoint of statistics in the data. This vector encoded molecule is called the latent representation of the molecule. Now we will talk about decoder. It takes in the output of an encoder and try to reconstruct the input as its output. While converting a molecule from a latent representation space to a molecule, the decoder model samples a string from the probability distribution over characters in each position generated by its final layer. So we have seen there are two vectors, standard deviation and mean. So they have been generated for normal distribution of the data. So from that distribution there will be sampling by the decoder and it will try to generate same output as the input. So various smile strings are possible from a single latent space. So you have single latent space, and from this your decoder is generating various smile, that is molecule. So it is called generative type of deep learning models. So from those various outputs you can use RDKit to check whether the smiles are chemically valid or not. So this can subsequently be used to preserve local similarities in a task dependent way. It can also enable generative network to design compounds with certain target property. So far we have studied that decoder can make various types of molecule which are similar to or resembling to input, but you can further fine tune those output by attaching some more mechanism for some target property. Means I want only those type of molecule from latent space which are having log p of 5 or which are having molecular weight less than 500. So to meet the criteria of drug likeness, you can further put conditions on the autoencoder. So that is called conditional autoencoder, because you are giving condition to the autoencoder, generate only those smiles from, generate only those output from the latent space which are meeting some predefined criteria. So latent representation can be trained on unlabeled data in an unsupervised or semi-supervised fashion. Creating another example from non-pharma world. So creating new styles of clothing. We could in fact just train an autoencoder on fashionable items and allow the network to learn a data generating distribution for fashionable clothing. So you will show an image of fashionable clothes, and then encoder will make latent space of those fashionable clothes, and from those latent space you can generate or sample different type of images of the fashionable items, or you can further fine tune them. Subsequently, we can take samples from this low dimensional latent distribution and use this to create new ideas, that is new fashionable items. So to sum up, autoencoder is a neural network architecture for unsupervised feature extraction. A plain autoencoder consists of an encoder, a decoder, and a distance function. The encoder is a neural network which maps high dimensional input data to a lower dimensional representation, also known as latent space, whereas the decoder reconstructs the original input from this lower dimensional representation. A distance function calculates the information loss derived from the deviation between the input and the reconstructed output. The use of this mathematical statistical term distance function is to understand, to measure how far the deviation is in output from the input. The goal of training is to reduce the information loss, to minimize the information loss, as the target labels for the reconstruction are generated from the input data. The autoencoder is regarded as the self-supervised, because what is the output, it should resemble to input. So already your autoencoder know the input and label also. Label means output, that is same input should be like output. Now so far we have seen basically about standard or vanilla or simple or the basic or the classical type of autoencoder. Now we will move to variational autoencoder. Variational autoencoder is a kind of generative machine learning algorithm. A generative machine learning model is a type of AI architecture which generates new data that is similar characteristically to the training data. It consists of two components, which are neural network. Already we have seen encoder and decoder. Different neural networks can be used for encoder and decoder. Suppose you want to make different sentences as output, then you have to use recurrent neural network. On the other hand, suppose you have to make molecular graph or the image of structures or the images of car or truck or some actor based on the input image, in that case you have to attach a convolutional neural network in your encoder setup. So VAE, that is variational autoencoder, uses a probabilistic approach for its encoder network, unlike regular or standard deviation. So this is the main point, and it go for probabilistic approach. This is main point. Vanilla autoencoders don't know how to generate good latent vectors apart from forcing the encoder to create just the latent vector. So these are two type of autoencoder, VAE and vanilla, that is standard. So VAE makes a specific type of output after taking sampling from probabilistic approach. On the other hand, standard or vanilla autoencoder don't know how to generate good latent vectors apart from forcing the encoder to create just latent vector from the training data. The latent space of vanilla autoencoder is not continuous, therefore they are not good for perfect for generating data. Not continuous means you don't have similar data points in a close proximity. In that case, you cannot go for proper sampling. So here I give you example. This is your input autoencoder, it is output. I love pancakes, it is English sentence. This is the input autoencoder, it will give into the French. This is the example or the application of autoencoder. Audio classification, you are giving some audio notes to the as a input, it will give you the example. Okay, this is sound of dog. Just by audio, it is audio to text conversion, right? Already some applications are there, audio to text conversion in Play Store. Now it is a variational autoencoder. In simple autoencoder, we have seen only image of input, encoder, and this latent vector, decoder and output. But here two more vectors are there, mean vectors and standard deviation vector. So these are the probability features or normal distribution we are ensuring by adding these two vectors. So from various features you have trained, for example, thousands of images of cats you have shown to a variational autoencoder. From those images, it will identify different mean of features and SD of the features. Then it will keep all the close features together so that during generating or sampling, it will generate only those images which are perfectly cat. In case of chemistry, in case of synthesis or drug discovery, suppose this is the structure of ibuprofen and this is the converted structure, that is the smile string, and this is the latent space, right? So this has been done by encoder, and from this latent space decoder will take more and more structures similar to this input structure. So in this area all the molecules will be similar. Here all will be similar, all will be similar. So you will choose one point from this and it will give you lot many structures resembling to input structure. So in true sense, this is the example of generative type of autoencoder, that is called variational autoencoder. So what has been done by latent space? In latent space, in a compressed fashion, in a compressed manner, you have put all your data points which are similar to each other in a close proximity, and from then after sampling you can generate various types of structure, and you can put some condition also, that is generate only those structures which are meeting some predefined criteria of drugs or synthetic scores must be there. Very beautifully example I have taken here. So this is the latent space. For example, this is your latent space. So here one cluster is only of dogs, one is only of this animal, only of giraffe. So suppose you will choose something from this particular cluster in the latent space, chances are almost fully there you will pick out only the giraffe structure. It is called the probability distribution concept, which is the more important or the most important feature of autoencoder in variational autoencoder. So these are the feature vector, these are the vectors, mean deviation or the standard deviation vectors are there. So this vector decide which particular image should be placed in the latent space, right? So this is sampling concept. You don't know what you are picking out, just pick randomly one image, and these are the feature vectors, these are the vectors, I mean these are the mathematical these are the values indicating some particular feature. So this value maps the output. So we don't know how to access this pool. Model finds these pools during training only. During training only, encoder sets latent space in such a manner that similar data points based on their standard deviation vector and based on their mean vector, they keep all the things similar in close proximity. And now when you will pick out one sample, you will get the right image. So here in this case, suppose this particular point is taken, so it is actually dog, other animal and giraffe, but suppose some sparse feature is there, there is no value in the space if it is not continuous. If it is not continuous vector and you sampled one particular feature, I mean image, and you will get this type of values, and then decode will give some noisy image, there is no output, it is a noisy output, noisy image. So here comes the role of variational autoencoder, because there is no sparse, there is no gap, the vectors are continuous. So whenever you will pick something, either it will be giraffe or dog or other animal, right? So here suppose you have taken one particular sample here, and decoder will give the image of cat. So it may not be something like cat, this one, but you can further fine tune, you can pick something from nearby area here or here. It is called probability distribution. Same for numbers, same for the molecular structure. So here there is the example in terms of drug discovery. You have a drug structure, this is the chemical compound, this one, this is the representation for machine learning, this is encoder, this is latent space. So all features in this molecule have been placed in close proximity, and decoder will give you another molecule which will be similar to input molecule. Now this is B. This is your structure encoder, and it will make two vectors, one for mean vector, one for the standard deviation vector, and this is the latent space. This is plain latent space. It may not be continuous in case of simple autoencoder. It is our variational autoencoder, right? Now from this normal distribution, if you take one sample, for example, you have picked one sample, it is 1, and likewise you can take n number of sample. Each time you will send sample to decoder, it will give some new image, it will give some new output, right? This is the job of latent. So ultimately your variational autoencoder is making latent space which will be used by decoder as generative model, and it will produce n number of examples. So this is another example I have taken from the famous website towards datascience.com, generating image with autoencoder. So this is the image of 2. It is your image or picture or input simply. Encoder will make random variables and decoder will give image of 2. Exactly how it is happening? The inherent nature of the learning procedure means that parameters that look similar stimulate the same network neuron to fire. Again I am reading here. The inherent nature of the learning procedure means that parameters that look similar stimulate the same network neuron to fire, and these are put together in the latent space and are not spaced arbitrarily. This is shown in the figure. In this figure you can see the value of 2 begin to cluster together while the value of 3 gradually becomes pushed away, because the neurons which are having 2 as the input, they are firing same output neuron. So the model understands, okay, I have to keep all this input together, so these are being in close proximity. For example, there are the structures for cancer treatment because they have some features in common, or they have some properties common, and this will be coming ahead. It is latent space. Here only 3 will be there, only 1 will be there. So 1 means different types of images of 1. There might be some changes in the angle or the dimensions likewise. Another example, an overview of the entire network architecture is shown here. Hopefully at this point the procedure makes sense. We trained the autoencoder using a set of images to learn our mean and standard deviation within the latent space which forms our data generating distribution. Next, this is your latent space. When we want to generate a similar image, we sample from one of the centroids. Different centroids are there. It is latent space. It is one centroid. For example, all the images of dogs, one centroid. All of giraffe, one centroid. Within the latent space, distort it slightly using our standard deviation and some random error, and then pass this through the decoder, and it will give us another image. If one save the encoded vector of an image or input, he she can reconstruct it later by passing it into the decoder part of the autoencoder. This is the concept of a standard autoencoder. We need to add a constraint on the encoding network that forces it to generate latent vectors that roughly follow a unit Gaussian distribution, and this is important. That is for normal distribution of the data in a bell-shaped curve, as I have just shown you earlier. If this is not the curve, it is not a perfectly normal distribution, and this separate a variational autoencoder from a standard autoencoder. So the input mapping to and from a lower dimensional space introduces a bottleneck, so that the autoencoder is compelled to learn to take only those features which are important for defining those inputs. The most common dimensionality reduction technique introducing an information bottleneck is principal component analysis. It take only the principal components or the main component or the main feature from the input data set, and it discards the unwanted one. The dimensionality reduction performance and the usefulness of the extracted features rest on the input data and the real architecture of the encoder and decoder network. It has been shown that recurrent and CNN network are successfully generating text sequence and molecular structures for generating new structures. So we can reduce the dimension through two techniques, either by feature selection, selects only some features and remove unwanted one. By feature extraction, transform input data into a latent representation. This is the subject matter of our present video, this one. The difference between these two techniques is that feature selection does not amend the features, while feature extraction edit the feature since it applies transformation to input data or input feature to arrive at the latent space representation. So for example, these are the latent attribute, these are the values, these are the vector values in the latent space, and you choose entire vector with these particular values, each representing some feature of the smile, skin tone, gender, glasses, yes or no, beard, yes or no, hair color, yes or no. I mean mathematical figures are there. So if after decoding you will get this image. Say for example, here is one image of the same gentleman, image, encoder, and this will be the latent representation. You pick the one input, you pick the one point, you will get the image. But if you have changed some features in the vector, you will get this type of image, completely distorted output. Why? This means that taking the latent representation in the above picture, the decoder is able to generate a decent looking picture. But if even one of the latent parameter like skin tone is changed just a bit from 0.85 to 84, then the decoder network gets completely derailed and might end up generating something like this. This is all because the latent space is not continuous. Very beautifully explained image from one paper already we have discussed in one video, that is to generate automatically drug like molecule through variational autoencoder. It is basically conditional autoencoder. Why? Because it is your input molecule, smile string, encoder, and this is the chemical, I mean the latent space. So in this particular area all molecule will be same compared to this one or this one. In this area in blue one all will be same. So you will pick one particular molecule from the latent space and you will find the its validity. It is simple structure. So far we have studied in autoencoder. But there is one more attached network for property prediction. Means it will produce only those molecules which are having some property which make it like drug like property. This is attached property. So already we have seen the beauty of variational autoencoder is that it is one of the best generative model that can be used to apply variation to the data one already has in desired direction. The same structure from another paper I have taken. Another example, you have this is conditional autoencoder. This is a structure. The two things are there. Two jobs are to be done by this autoencoder. One, to generate in output only those molecules which resemble like input, and they should also have some property like log p value, solubility. All those things should be incorporated while training. Then only these two input, that is the molecular structure and desired property, then it will generate only those structures which meet all these two property. Two property means structure like your input and physicochemical property, for example binding score, log p, molecular weight, solubility, and so on. So it is called conditional variational autoencoder. This is the difference between two type of autoencoder, just we have seen multiple times, and another examples already we have summarized. So with this particular video, I hope you have learned the meaning of autoencoder, meaning of variational autoencoder, and how do they different from each other. In another video, now we will talk about adversarial autoencoder. Thank you very much.